Good morning, Year 6. This is Thursday's maths lesson, and the work today is to convert, simplify and add fractions. So your recapping is going to be your fluency as well. So when you're adding or subtracting fractions, don't forget that you've got to make sure the denominator is the same. If it's not, you need to find a common denominator before you can add or subtract them. So have a go at those ones. Quite simple to start with, and they will get gradually harder as we go through. Okay, so the first one, like I said, is quite straightforward because the denominator is already the same. So 3/5 add 1/5, we keep the fifth the same, and we add the numerators. 3 add 1, which is 4. And the second one, we've got 1/4 add 2/3. On this one, we have got different denominators. One of the easiest ways to find a common denominator is to multiply them both together. So 4 times 3 is 12. So your new denominator becomes 12. But therefore you need to change the numerators as well. So what have you done to 4 to change it into 12? You've times it by 3. So you need to do 1 times 3 to make 3. So 1/4 is the same as 3/12. Then moving on to your thirds, 2/3. What have you done to 3 to change it into 12? So you've times it by 4. So you need to do the same to the 2. 2 times 4 is 8. So 2/3 is equivalent to 8/12. So your question now is 3/12 add 8/12, which is 11/12. So you should have all got that one correct. Or you should have definitely got the fifth one correct. So simplifying fractions then, and again it's something that you've done before, it's just a recap. So we're finding a common factor of both the numerator and the denominator. So for example, for 12/16 they can both be divided by 4. So you're finding a number that can go equal into both of them. So 12 divided by 4 is 3, 16 divided by 4 is 4. So 12/16 can be simplified down to 3/4. That means that they are equivalent fractions. Have a go at simplifying the bottom ones and then press play. So 4/8 can be simplified down to a half because 4 goes into 4 once, 4 goes into 8 twice. 3/15 can be simplified to 1/5 because 3 goes into 3 once and 3 goes into 15 5 times. 9/15 can be simplified to 3/5 because 3 goes into 9 3 times and it also goes into 15 5 times. 24/30, on this one we're going to divide each one by 6. So 24 divided by 6 is 4, 30 divided by 6 is 5. And the next one, 18/30, we're also going to divide it by 6. So 18 divided by 6 is 3, 30 divided by 6 is 5. And then for the last one, we're going to divide them by 4. So 4 divided by 4 is 1, and 12 divided by 4 is 3. So on this one then, what I want you to do is add them together. We've got the denominators the same to make it a bit easier, but then once you've added them together, I want you to simplify them into their simplest form, so the lowest that they can be. And then it says, do all the answers need simplifying? Explain why. Okay, so the first one then, we've got 5/9 add 1/9 is 6/9, and then we can simplify that because 3 goes equally into 6 and it goes equally into 9. So when I say equally, I mean with no remainders. So how many 3's are in 6? 2. How many 3's are in 9? 3. So 6/9 can be simplified down to 2/3. Next one, 5/9 add 3/9 equals 8/9. That can't be simplified. So that's going to answer your question at the bottom, do all of them need simplifying? No, they don't, because the middle one can't be simplified because there's nothing that can go equal into both of those, into both 8 and 9. And then the last one, 5/9 add 7/9. This is going to give you an improper fraction. It's going to give you 12/9. So for this one, we need to convert it to a mixed number. So to convert it into a mixed number, we say, right, well I know that 9/9 equals 1 whole. So 9 goes into 12 once, and then you've got a 3 left over. So you get 1 whole and 3 9s. So your 1 whole is 9 9s, and then you've got remainder 3, which becomes 3 9s. And then you can simplify that. When it comes to simplifying, you don't do anything to that whole number, because that's just there, that's a whole number, it stays as it is, and you simplify the fraction. So what number can go equally into 3 and 9? The answer is 3. So how many times does 3 go into 3? Once. How many times does 3 go into 9? 3 times. So the answer is 1 1/3. And then we've already answered that at the bottom. They don't all need simplifying because you can't simplify the middle one. So on that last slide we had a brief look at converting a mixed number or an improper fraction into a mixed number and vice versa. So I want you to just have a go at these ones. So on the left you've got some improper fractions that need to be converted into a mixed number, and you've got some mixed numbers that I want to be converted into improper fractions. If you're not sure how to do it, just go straight onto the explanation. If you've got an idea how to do it, have a go and then wait for the answers to check if you got them right. Okay, so 7 quarters. We know that 4 quarters makes a whole. So basically you're saying how many times can 4 go into 7? 4 goes into 7 once. What's left over? The answer is 3. So that becomes your numerator. So you've got 1 whole 1 and 3 quarters. For the bottom one, how many times can 3 go into 9? It goes into it 3 times. There's no remainders, so there's no fraction there. So it's just 3 whole 1s. Okay? Because 3 3s or 3/3 is 1 whole 1. Another 3/3 is 2 whole 1s. And another 3/3 is 3 whole 1s. And that's what you've got there. Next one, 37 halves. So how many 2's go into 37? So it's 18 whole 1s. And how many is left? 1. So 2 times 18 is 36. So you've got 1 left over, so that becomes your numerator. How many 4's are in 39? It's 6, remainder 3. So it's 6 3/4. And as you can see, that denominator never changes, it stays the same. Going across them, we've got our mixed numbers and we need to convert them into improper fractions. So this time we need to get our whole number and multiply it by the denominator. So for every whole one, for the first one, we know that for every whole one we've got 9 9ths. So if we've got 3 whole 1s, we've got 9 9ths 3 times. So we do 9 times 3, which is 27, and then add that extra 1. So we've got 28 9ths. So at the bottom, we say 4 times 15, which is 60, add the 11, which makes 71 15ths. And then going across, 2 times 8 is 16, add 7 is 23, so it's 23 8ths. Again, you can see that that denominator's never changed. And then 6 2/5, 6 times 5 is 30, add the 2 is 32 5ths. Mark those and correct them if you didn't get them quite right. So moving on to some problem solving and reasoning then. Tommy is simplifying 4 whole 1s and 12/16ths. So he wants to simplify it down to the lowest it can be. He says that 4 whole 1s and 12/16ths simplified is 1 whole 1 and 3/4. Explain Tommy's mistake. So it's telling us it's wrong, but how or why is it wrong? Off you go. Okay, the reason it is wrong, because although he's correctly simplified the 12/16ths into 3/4, because he has divided both the numerator and denominator by 4, so he said, right, okay, 12/16ths, I can see there that both of those are in the 4 times table, so it means I can divide them both by 4. 12 divided by 4 is 3, 16 divided by 4 is 4, so that gives me 3/4. So that bit's correct, but then what he's also done is, he's taken his 4 from the 4 whole 1s and he's also divided that by 4. And he should have kept it as a whole number. So for example, if you've got 4 whole cakes and 12/16ths and you simplify it, you don't suddenly just end up with 1 whole cake, you've still got 4 whole cakes. But that 12/16ths is just equivalent to 3/4. So his answer should have been, he's still got 4 whole 1s and it's 3/4. Okay, sort the fractions into the table below. So you need to look at the fractions on the right hand side and put them in to either halves, thirds or quarters. And then it wants to see if you can see any patterns between the numbers in each column, and then what's the relationship between the numerators and denominators. And finally, it wants you to add 3 more fractions of your own to each column. Off you go. Okay, so the answers are as follows. So to simplify to a half, we've got 2 quarters, 8 16ths, 6 12ths and 5 tenths. Simplifies to a third. For some reason I've put an extra third in there, I don't know why, because it's not on the cards at the side. So we've got 5 15ths and 3 9ths, and then to simplify to a quarter, we've got 4 16ths and 2 8ths. Can you see any patterns between the numbers in each column? So if you look at the denominators, you should be able to see a pattern there. So for the fractions that are equal to a half, you should notice that all of those denominators are all multiples of 2. So they're all in the 2 times tables. For the thirds, they're all multiples of 3. So 3, 15 and 9 are all in the 3 times tables. And then for the quarters, they're all multiples of 4, so they're all in the 4 times tables. Then it says what's the relationship between the numerator and denominator. So for the fractions that are equal to half, the numerator is always half of the denominator. For a third, the numerator is always a third of the denominator, so it means it goes into it 3 times. So 5 goes into 15 3 times, 3 goes into 9 3 times. And then the same with a quarter. So the numerator is always a quarter of the denominator, so it goes into it 4 times. So 4 goes into 16 4 times, and 2 goes into 8 4 times. And then you can add some of your own to each column. So for this one, it wants you to use the digit cards to complete the statements. So something quarters is more than 6 what? And then something quarters is less than 6 what? And it says find 3 examples of ways that you can complete the statement, and it wants one of those to include an improper fraction. Off you go. So, like I said, there's different combinations of answers for this. I've gone with 5 quarters is greater than 6 sixths. And I know that because 6 sixths is 1 whole 1. 5 quarters is obviously more than 1 whole 1 because 4 quarters would make 1 whole 1. So automatically there I know that 5 quarters must be more than 6 sixths. Going across, this time I've gone with another whole 1, so I've said 4 quarters. And that's going to be less than 6 thirds, because 6 thirds is going to be the same as 2 whole 1s, because 3 goes into 6 twice. So 1 whole 1 is less than 2 whole 1s. And if you look, I've only used each digit card once. So it says find 3 different examples of ways that you can complete it. So you might have different versions of that. And then it says, can one of your ways include an improper fraction? So on mine I've got 2 improper fractions there. I've got 5 quarters and I've got 6 thirds. Okay, Teddy is comparing 3 eighths and 5 twelfths. When it says he's comparing them, what it means is he's trying to see which one's biggest and which one's smallest. Okay, so he wants to find the lowest common multiple in order to make them so that they've got the same denominator. So he's going to find the lowest common multiple for the denominator by multiplying 8 and 12 together. So he's going to say, right, 8 times 12 is 96. And we said earlier that that's probably the easiest way to find a common denominator. However, if you look at the question, it says the lowest common multiple. So although 96 works, is it the lowest one? Have a look at it, see whether you agree with him or see whether you think the answer is different. Off you go. So, Teddy is actually incorrect. And the reason that he's incorrect is because, first of all, let's just look at what multiples are. So the multiples of 8 are the numbers in the 8 times table. So 8, 16, 24, 32, 40 and so on. And the multiples of 12 are the ones in the 12 times table. So 12, 24, 36. So although 96 is in both the 8 times tables and the 12 times tables, because it's 8 times 12, is it the lowest possible answer? Okay? The common multiples are the ones that are in both sets of times tables. So although he's right in saying 96 is a common multiple of 9 and 12, it is not the lowest. And if you look at those there, it says the multiples of 8 are 8, 16, 24, 32, 40 and so on. And the multiples of 12 are 12, 24, 36 and so on. And straight away there you can see that the number 24 appears in both of those times tables quite early on. It's the first number that appears in both of them. So the lowest common multiple of 8 and 12 is 24, because 8 times 3 is 24 and 12 times 2 is 24. So if it had just said find the common multiple, 96 would have been fine, but because it said find the lowest common denominator, it had to be 24, so he is incorrect. Okay, we're almost done. If you've made it this far and you're doing alright, carry on. If you're starting to struggle a bit, don't worry, you can just carry on and just look at the explanations, or you can have a break and come back to it, or you can say to yourself, right, I've done enough for today, I think I need to move on. What I would probably say is if you're struggling, just carry on watching the video so at least you get to see the explanations, but don't necessarily have a go at them. Okay? So, use the same digit in both boxes to complete the calculation. Is there more than one way to do it? Have a go, first of all, and then see if there's more than one way to do it. Okay, so something 20th plus 1 something equals 9 20th. Now the most obvious answer is for that is going to be, what do I add to 1 to make 9? And then you keep your denominator the same. So 8 add 1 is 9, and you keep your denominator of 20. That's the most obvious answer. But are there any other answers? You can do it differently by changing the denominator to a factor or multiple of 20. So for example, if you said I'm actually going to do something 20th add 1/10. So 1/10 is equivalent to 2 20ths. So your question now is something 20th add 2 20ths equals 9 20ths. So what do we add to 2 20ths? We add 7. So 7 20ths add 1/10, which is equivalent to 2 20ths, equals 9 20ths. So then, if we do 5 there, have a guess, what do you think the answer is going to be to the 20ths? Pause it again if you need to. So 1/5 is equivalent to 4 20ths because we times 5 by 4 to get 20, so we need to times the 1 by 4. So basically it's saying how many 20ths do we add to 4 20ths to make 9 20ths? So your answer there is 5. I've just realised that it says use the same digit in both boxes to complete the calculation. So that's the answer then, it's the 5 one. So the answer is 5 20ths plus 1/5. So although the other two work, the only actual answer is the 5 20ths plus 1/5. So that's me not reading the question properly, so you can have 1 point for that year 6. Okay, nearly done. It says Dexter subtracted 3/5 from a fraction and his answer was 8/45. What fraction did he subtract 3/5 from? And give your answer in its simplest form. Okay, so first of all you can see that the question looks something like this. It says something subtract 3/5 equals 8/45. Problem there straight away is that the denominators are different. So first of all we need to convert that 3/5 into 45 so that we're working with the same denominator. So what have we done to 5 to make it into 45? We've times it by 9, so we'll do the same to the 3. 3 times 9 is 27. So now your question becomes something take away 27/45 equals 8/45. And in order to work that out, we need to do the inverse. 8 45ths plus 27 45ths equals 37 45ths. And then it says give your answer in its simplest form. So we need to find a common multiple. A common multiple that can go into both 35 and 45, the common factor is 5. So how many 5s are in 35? The answer is 7. And how many 5s are in 45? The answer is 9. So 35 over 45 can be simplified into 7/9. Final question. Alex is adding fractions. 3/5 plus 1/15 equals 4/20, which can be simplified to 1/5. Do you agree with her? Explain your answer. No, you don't agree with her, or you shouldn't agree with her, because all she's done is she's gone across the numerators and she's added those together to make 4. 3 add 1 is 4, and then she's added both the denominators together. So she's made the classic mistake there. What she should have done is converted it so that both denominators were the same. So she should have said 3/5 is equivalent to 9/15. I know that because I times 5 by 3 to get 15, so I times 3 by 3 to get 9. So the question becomes 9/15 add 1/15, which equals 10/15, and then that can be simplified by dividing the numerator and denominator by 5 to make 2/3. Okay? Any of those that you struggle with, maybe go back, have another look at them. And please give me some feedback. I know some people have been doing video feedback or messages to let me know how you've been getting on with it. And don't forget to upload your pictures. You don't need to upload every single one, just one for maths, one for English, and one for your foundation subject. Enjoy the rest of your day, and I will speak to you soon.